Hello again, everybody. Oops. The alumni speaker for this year's World Finals. First, let me introduce myself. My name is Jelani Nelson. Is there a lot of feedback, or can you guys hear me well? You can hear me. Okay, great. Okay. So in my day job, I work at UC Berkeley. I'm a computer science professor there, and I'm also the coach of the UC Berkeley team, which is here somewhere. But also here at the World Finals, I'm serving as the director of the Alumni Speaker Series. Finals speaker, Andrew He. Andrew competed in the ICPC twice as an undergraduate for the MIT team, winning a silver medal in 6th place with his team at the 2016 World Finals in Phuket, and a gold medal and 2nd place in 2019 in Porto, Portugal. His strong performances at the ICPC have been mirrored in many other contests. He's won 2 gold medals at the IOI. He was the winner of the USAMO in 2013, which is an American math contest, K-12 math contest. He was the champion of the Facebook Hacker Cup in 2021. Twice got 3rd place in the Google Code Jam finals, and was also the champion of the 2017 Distributed Code Jam. 2nd and 3rd places at Top Coder Open Finals, champion of the Top Coder Marathon in 2015, and several other notable contest performances as well. I won't list all of them. He goes by Eknarwala on Codeforces, which I learned is his first initial and middle name backwards on Codeforces, where he is a legendary grandmaster. Since graduating from MIT in 2019, Andrew has regularly attended World Finals for the ICPC, serving as staff for ICPC Live. He's also worked at several startups and now is at Cognition Labs, where he is a member of the founding team. Their most well-known product is Devin, the first AI software engineer. And without further ado, I'll pass it off to Andrew, and thank you for coming to give this talk.
All right. Thanks, Jelani. Can everyone see the slides, and can everyone back at the World Finals? And yeah, today I just wanted to share a little bit about what we've been doing at Cognition, things that I've been working on, and also just give you guys a taste of some of the problems that are out there for you guys to work on, and the kinds of things that you guys could be building. Without further ado, I think I'll just jump straight into a quick demo of Devin. So as Jelani said, Devin is our AI software engineer. And this is what the Devin website looks like right now. Pretty much, Devin is Devin's interface is a little bit like ChatGPT's, except that Devin actually has access to a real computer and can do real things on this computer. So here's an example of a run I asked Devin to do. I said, oh, please, can you go check out my competitive programming library? And constraint, I'm sure many of you guys have some similar code. The point of it is if you have a bunch of equations of the form, I can kind of combine all these constraints into a constraint on the LCM of all the mods. And this is some code that I'm sure many of you guys have. You use like Chinese remainder theorem and things like that. And I actually just wanted Devin to write some tests for this code. So Devin is really quite autonomous. So all you need to do is start by just telling it a little bit of what you want it to do, and Devin is able to we'll actually just go and clone the repo. We'll actually set it up, and we'll actually just start working on it. So the first thing that Devin tries to do is clone the repo off GitHub, and then it'll go and it actually went and installed CMake. It saw that CMake wasn't installed, which is the build system I was using, and actually went and installed it without too much fanfare. And then I started off just by asking it to write a quick test. So in my repository, there's a lot of these little like test files that kind of you just provide some test code and you check some assertions. And in this case, for this mod constraint, the assertions are pretty clear. It's like if you have two constraints, you want the output of their union to be like to match each of the original constraints. So you want like the value mod A's mod to be equal to A's value, and you want the value mod B's mod to be equal to B's value. And so Devin, and how you use require, and Devin actually went and found these just by looking at the adjacent code. So this is kind of something that's uniquely. So after doing this, I asked Devin to actually expand the test a little bit and put them into a for loop and kind of loop over all cases. And one thing Devin found was that actually the code actually wasn't passing correctly. At some point, one of the requires, I don't know if you guys can see this, but the require said that we wanted the value mod B to be equal to the original value, and somehow the value was -4, which clearly I did something wrong in my CRT if I'm returning a negative number. And so Devin actually went and actually started to debug this. So if you look in here, Devin actually went and added like some some print debugging. This is a lot like how you guys might be debugging, in the coming few days at the contest. And it's able to actually print out and fixed all this. And from here, all the interaction I had to do was kind of just talking to Devin and asking it about what it changed. So I asked, what changes did you make to fix the problem? And it told me, oh, there was this variable extra, and if extra was sometimes negative because we took this mod operation and we didn't add this extra line, which is, when you take some mod, you have to, in C++, when you mod something, if the input is negative, the output is negative, and that's not what we wanted. From here, you can keep talking to Devin about a lot of these things. So, I asked Devin, oh, can you remove the extra print statement? Can you, fix up any imports? And at the end, I just asked Devin to create a PR, which I've actually since merged into this code base. So the PR, if we open up this PR has actually been merged and is actually what I'm using now in my actual programming library. So I think the point of this is just that there's so much that we can do with these agents that have a little bit more capability to actually write code and edit code and run code that kind of unlocks so many more use cases. And beyond this kind of like small, my small programming library, Devin is really built to work on any size code base. So we use Devin all the time in our own code base. I won't go through this whole run, but if you look on the left side, there's kind of a list of sessions. If any of you have, this is what like so many websites look like. And there's this list of sessions, and you can click through them. But there's this little search bar to search through your sessions by name or something. And this was actually built by Devin. And the workflow to build this was really very easy for us. All we had to say was, can you go into the Devin sessions list? Can you create a search bar component that lives under the button group? And Devin went and did pretty much the whole task without too much additional input. It went and started the session. It created the search bar. It even went and tested it. So on the right side, you can see that Devin actually has a browser. And in the browser, Devin can load up the development website and actually use the search bar to make sure that it's actually searching correctly. So all of these things are really key aspects of software engineering that we're really starting to unlock, where you can actually develop code and then you can test it and you can validate it and you can debug it interactively, and that's kind of what we're hoping to unlock. With that, to just step back a second and talk a little bit about how it started. So Cognition, I guess the Cognition officially started like late last year. But really the start of the story is probably around 2007, 2008 or something. Because that's when so many of us kind of started to do these math contests and programming contests and really met each other for the first time. So this here is a picture of IOI 2014 in Taiwan. And in the middle is that from on my side is over here is me, and then Steven, and then Scott, and that's Josh, who's now who is not at Cognition, but is I think a PhD student now, or just finished his PhD. And kind of we first met doing these contests, and these contests are just such a great avenue to meet other smart people who are also interested in programming and are interested in building things and are good at it too, you know. So ever since high school, we've kind of been really good friends. Here's another picture of us, all of us at ICPC World Finals 2016. On this side, this is the MIT team. That's Brian, Steven, and me. And then on the right side, there's Scott on the Harvard team, and also Jelani was the coach of the Harvard team that year. We did a lot of practicing together, and it was a lot of fun. And I guess since graduating from college, we've all kind of done a lot of different things. I'll just say briefly for myself, like I graduated college in 2019, and I worked at a couple different startups doing various AI platform things. And in like late last year, we kind of all came together. I think Steve and Sky and I kind of started kind of exploring some ways of like we started playing with some of these large language models and playing with some of these APIs to try and just explore what might be out there. We didn't know that we wanted to found a company yet, but we were just interested in trying to get some interesting results and trying to just get our hands dirty. Well, what we found that it was pretty interesting, and what we ended up doing is November 2023, we actually went and just booked an Airbnb for a week in the Bay Area, and we emailed like everyone we knew. We emailed a lot of people we knew from the contest community, people that we knew from work, and we just invited everyone to come and hack for a week on these LLMs. And kind of since then, the rest is history. From there, we kind of realized that just how powerful these things had kind of really become, and our experiments with building this into a real product pretty much led us to actually found Cognition. So these are some pictures of us, I think in New York and in the Bay Area. We've done a few hacker houses in various places. We've kind of finally, we used to actually move between the coasts a lot, but we've kind of finally settled in the Bay Area. And yeah, now we're building Devin. So I guess the main thing I want to share here is that really the people in this room are actually like some of the best people that you would work with, and it's just a great network to leverage and to kind of find the people that you might want to like keep working with, and just find other smart people to build things together with. A little bit about why we built Devin, and why we built Devin in particular. The first big wave of AI products that we've seen in recent times has been all of these text completion models. So they've all had the basic framework of you give it some text, and it just continues to add on extra text. And these models, this can be of the form you ask it questions and it gives you answers. But fundamentally, they're all limited by the fact that it's just text. Sometimes text is valuable information, but it can't really take actions or interact with the world. And that's really what's about to change, I think, in kind of the next wave that's coming up right now. It's that we're going to start getting these agents which can actually make decisions, can actually interact with the world, and can, most importantly, take feedback from their actions. So they can run the tests, and then they can actually look at the results of the tests, or they can open up a website and actually look at the information gathered from that website. And so building these things is very it requires both a lot of capabilities on the underlying models and a lot of capabilities to actually reason about all this information and what the best planning and the best course of action is, as well as a lot of interesting product design. These agents really are much more human and much more like they're much more like employees to manage than before. And so building good interfaces to interact with them and to work with them is also a pretty exciting problem. Yeah, there's a lot of pieces of this that we have to build. There's things, different ways of teaching Devin things, kind of giving Devin resources and knowledge about the particular code bases. There's things like tooling for Devin, so we need to make sure that Devin is able to use a browser and is able to use Bash. And there's all these, there's a lot of ways of communicating, and at the center of this all is kind of the plan and the brain of how to make Devin, choose to use the tools and the resources it has as best as possible. I'm going to switch gears really quickly and talk a bit about one particular technique we use. We use this most editing component of Devin. And if you guys have seen things about how LLMs work, probably this won't be too new, but hopefully I'll be able to share something that you haven't seen before. So I guess who here knows how LLMs are structured? A few hands. OK. I'll give a quick overview. So LLMs fundamentally are big machines that predict the next token. So in this example, I've drawn this LLM from kind of the bottom to top, and at the bottom is kind of the first thing you get is you get the first input token, which is maybe public. And if any of you guys have used Java, the natural thing that you complete is public static void main. And the first thing you do is you take public and you run it through a bunch of different layers. Each of these layers, it's a little complicated. They're roughly like a multiplayer perceptron, if that's something that you know. It's big matrix and then some ReLU gates. And each of these layers is kind of a big block of computation. And actual transformers that people use these days have hundreds or maybe thousands of layers. But here I've just drawn 3. And you push it through these layers, and the output of these layers eventually becomes the best guess for the token that it thinks is coming next, which is static. So what you do then is you take static and you push it through the same network, the same 3 layers. And as you push it through these layers, the key difference here is we actually feed static's layer 2 the output of public's layer 1 as well. And we also feed static's layer 3 the output of public's layer 2 as well. So it's kind of like every token is getting pushed upward, but there's also these cross edges that feed information laterally. This cross edge mechanism is called attention, and that governs exactly how you merge these different signals. But this is the high-level data flow. And for the third token, if you get void, then maybe the next token you predict is main. And one interesting thing about this is that actually this process is very serial. I mean, it kind of has to be, right? If I'm trying to predict the 4th token, I have to predict the 3rd token, and then to predict the 3rd token, I have to do all 3 layers to predict the 2nd token, and so on. So the critical path to actually generate a token is actually very long. And this is sometimes not a big deal, but usually we're trying to make things faster. And so this is something that we'd like to improve on. And so the technique here is called speculative decoding. And the main idea is that you start by having the best guess of what the output stream is going to look like. And there's a lot of ways of getting the best guess. One thing, there's many of them involve you can run maybe smaller models, cheaper models to get this better guess. Maybe you can run, maybe you just like know what it should output. Or maybe in the case of editing, one good way of guessing is if you're trying to edit a particular file, a good guess for the results of the new file is just the results of the old file. And what we do is we kind of just put all of these best guesses into the bottom layer at once. And one nice thing about these transformers is that they actually parallelized very effectively. This is also the key behind why is very fast. But what we'll do here is we can actually compute all of the layer 1s at once, and all of the layer 2s at once, then all of the layer 3s at once. And this is much faster. I guess for context, all of these are running on GPUs, and GPUs are very parallelizable machines. So GPUs can do some amount of computation. GPUs can do some amount of computation pretty quickly, but they can do a lot of that same computation in parallel very quickly. And it's not quite true that GPUs are infinitely parallelizable, but you can definitely saturate them better if you have more things going at once in parallel. And so by doing this, we're able to take maybe not the total amount of compute that was done down, but we're able to take at least the critical path down from having to go through all the layers for all the tokens down to just all the layers for one token at a time. And there is this that if the LLM decides that, oh, actually the output of the third token isn't void, it should be int, then you actually do have to kind of break your speculation. If any of you guys have done CPU design or architecture, this is a very you're flushing your pipeline because you have pretty much you have like a cache miss or something. And now you do actually have to go and recompute the entire fourth token based on the starting input. And so you want to avoid this, and you also want to recover from this as gracefully as possible. So there's a lot of space for optimizing different ways of, how far ahead do you want to speculate? Because the further ahead you speculate, the more likely you are to be wrong. And kind of how do you best design what the speculative input is? And so this is kind of a quick taste of some of the things that we think about and how to optimize some of this LLM inference. I'm happy to talk more about any of these things after the talk. But for now, I'm going to move on and quickly give some thoughts on kind of what's next, what the future of software is. What will Devin look like in 2 to 3 years? And I think there's so much space that this could take on. I think the most likely thing, well, almost certainly Devin and other software agents, if they exist, are just going to be much better, right? They'll be able to do, if they can do maybe today they can do intern tasks, and in 2 or 3 years they'll be able to be several steps up along the corporate corporate ladder of kind of developer productivity. And the way programming is going to work is it's going to change so much. As you saw in some of the demos, all it takes to develop websites now really is just asking about what website you want to develop. And so if you ever wanted to make a website for maybe a activity or just a project for your friends or anything, it's all just becomes so much easier, and not just for you guys, but also for people who are not as familiar with code, right? And who don't code and build regularly. And that's really just going to unlock so many more applications of code. And there's just so much more code to be written. Software engineering is also going to change a lot, right? When we're able to kind of delegate the smaller bite-sized tasks down to these autonomous agents, it kind of really frees us up to take on bigger, higher level tasks. And it frees us up to kind of, it puts us all more in a role as a manager almost, where we have a fleet of interns that we can ask to do various things. And we kind of get to focus on things like the architecture or the product or the high level ideas of what we're building. And I just want to like look back a little bit too. Software engineering has changed a ton over the years, right? Like, how many of you guys have ever touched a punch card? Probably, like, I don't see any hands. Oh, one, two, okay. Yeah, mostly coaches, I assume. Yeah, yeah. So, like, software engineering used to be about like punch cards and writing algorithms very clearly, and then it was about, like, there was a lot of assembly, and there's been C, and nowadays, all our code is written in Python or JavaScript. And kind of over time, we've just taken our constructs and made them higher and higher level, right? It used to be that you had to express exactly what you wanted the CPU to do, and now you get to express exactly what you want these objects to do, or you want these web pages to do, or these components to do. And pretty soon, we're going to be able to directly express what we want our programs to do in high-level English. And I think that's really exciting. And I think that's like, that's what we're striving. That's what the kind of change we're striving to enact. So with that, I think that's pretty much all the talking I had prepared. I wanted to kind of take the rest of the time and open it up to any questions or anything if you guys want to, if you guys have anything to ask. So I think there are a few mics that we can pass around. Does anyone know where they are? And yeah, does anyone have any questions?
Please use the microphone, or nobody will hear you in the recordings.
Yep. Oh, give us a second.
One, two, three.
Okay. Yeah.
A question: how did you come up with the name Devin?
How did we come up with the name Devin? Let me think of it. I guess the very first version, the prototypes that we built were kind of, I don't really know why we called them that, but the first prototype that we built was called, one of the first prototypes we built was called Dev Walden. It was built by Walden, who's one of our founders, and he just wanted to experiment with like a particular agent. I don't think any of that code is in Devin today, but that kind of like, we were like, oh, maybe, I think Steven then started to build Dev Steven, and we eventually came to the point where we are like, well, we need a name for this product. And we were like, well, dev is pretty good. It's like, we want it to be a dev. And then, I don't know, eventually we came up with the name Devin, and which is what it's doing. It's Devin. And I think that we just ran from there. Does anyone else have any questions?
Over here.
How does the process of developing LLM usable tools differ from the process of developing human usable tools?
That's a really good question. I don't need to repeat these questions, right? I guess I'll just repeat them for good measure. The question was how do developing tools for LLMs differ from developing tools for humans? And I think at a high level, they're very similar. All the information that's useful for humans is also useful for LLMs. So things like compiler errors, like the red squiggly is under your code. They're useful for humans because they help us fix our code faster, and they're useful in the same way for LLMs. I think so. In general, like the one point of view is like you kind of want to pack in a lot of the same information. But there is another side, which is that humans a lot of human tools are built for this flow that LLMs today are not very well suited for. And maybe this will actually change as people like develop new LLM architectures. But the flows that are good for humans are very interactive. They have very, very fast feedback loops. So on my keyboard, and I can see my IDE updating in real time. Or I scroll a little bit, and my view changes a whole lot, right? And humans are very good at this, where we have excellent vision, and we have very fast processing of new stimuluses. But LLMs today are not very good at that. LLMs today are actually very good at consuming a lot of text, right? They have like very large context windows that they can consume essentially instantly, right? The largest LM context windows are like millions of tokens or something. And so this kind of has this separate modality where you'd rather just, you can, instead of trying to like have it, give it feedback on every small thing, you can instead give it a lot of feedback all at once. So when you open it, you open some code in an editor, multiple files of context all at once. Or if you open a browser, you can give it like the whole web page, and you can also give it a lot of the HTML markup because it's just good at processing this text faster than a lot of humans can. So things like this are like, there's a lot of trade-offs and there's a lot of different modalities in terms of developing tools for LLMs.
Next question.
Hi, I'm around here. It was very cool. I really enjoyed the demo at the beginning, and my question is to that. So my feeling was that it's really cool, but still I felt like there's a lot of ceremony to say, hey, look at this part of the code and do this and do that.
Yeah.
And my question is, how much do you think, well, I'm sure it's also going to improve, but how would you rate, do you think mostly this was good to be able to do it like that because it was faster than if you did it yourself? Or is more the benefit that you don't really need to, like someone who might not be able to do it at all, or combination of the two?
Yeah, I think there's, I guess both. There's definitely a little, like kind of analyze games with computers in order to like kind of try and their own intuition. And I think that could happen with competitive programming. I think one caveat is like, we're not in the phase yet where no human will ever beat a computer, right? Maybe we'll get there at some point. If we do get there, like, dude, the world's gonna be great, okay? Like, if computers can solve like hard IOI problems and hard ICPC problems, like, computers will be able to solve things like, nuclear fusion or whatever we want, and we'll be super happy. But like leading up to that, I think, we'll see more like. We'll have to be a little more careful with cheating, and we'll have to be careful with like enforcing rules, and that'll be pretty tough with online competitions. But at least we have competitions like these, and I think we'll generally see like people will continue to do the sport because it's a fun sport. Yeah, question up here. I don't know. I saw a question over here. Oh, let's. Okay. So I think we're kind of running a little low on time. We have opening ceremony next, and so I will pass it off to John Clevenger, the World Finals Technical Director, to give you guys some instructions. Thank you, guys. Oh, sorry. Let me just say one more thing. Like, if any of you guys are interested in, talking more about this or have any more questions, I'll be around, the whole week. If any of you guys are interested in working at Cognition, let me know. Thank you guys for having me. And see you guys around.
About a nice round of applause for Andrew He. Thank you, Andrew. As Andrew said, my name is John Clevenger. I'm the technical director for the ICPC World Finals. I was asked to just come up here and make a couple of announcements. First of all, is the team from Nanyang IT University here? Anyone from Nanyang IT University here? That team is asked to go to the ICPC office right away. They need to talk to you. Some information about the opening ceremony. Immediately after I'm done here, we'd like to ask everyone to please go to the parking lot out in front of the building to board the buses to go to the opening ceremony. It's important that everybody understand that there are stringent security rules at the Presidential Center where the opening ceremony is going to be. And in particular, due to building security, there's a problem with if you're bags into the opening ceremony. So please, if you have team members, team guests here, please leave your bags with them here. If you take bags over to the opening ceremony, you're going to get diverted into a separate security line, and you're going to have